This story began more than 14 years ago. In 2012, one man made a decision that shocked the entire world. Felix Baumgartner was about to stand nearly 128,000 feet above Earth, with nothing but a pressure suit standing between him and death. Millions of people were watching live. Every movement was broadcast across the globe. One small step forward, and there would be no turning back. Everything had been calculated down to the smallest detail. Yet no calculation could remove the risk waiting ahead. Seconds later, Felix left the safety of the capsule. Gravity immediately took control. There were no engines pushing him, no wings supporting him, only the silent pull of Earth beneath him. As he descended through the thin upper atmosphere, his speed increased every second, faster and faster. The higher the acceleration, the closer he came to a limit that had challenged engineers and pilots for decades. Soon, his velocity approached the speed of sound. For most people, this may not seem unusual, but every aerospace engineer knew exactly what should happen next. And none of it was good. The sound barrier isn't a physical wall. You can't see it and you can't touch it. Yet it is one of the most violent regions an object can pass through while moving in Earth's atmosphere. As an object accelerates, it pushes air molecules out of its path. At ordinary speeds, those molecules simply move aside. But as the object approaches the speed of sound, the air can no longer get out of the way fast enough. Instead, the air begins to compress. Pressure builds rapidly in front of the moving object, creating an invisible wall of compressed air. This is the beginning of a shock wave. When that shock wave finally forms, enormous pressure is released almost instantly. Aircraft crossing this region experience violent aerodynamic forces that engineers spend years learning to control. Modern supersonic aircraft are built from advanced alloys and carbon composites. Every surface is carefully engineered to survive these extreme forces. Felix, however, was not flying a jet. He was simply a human body moving through the sky. A human body is incredibly fragile compared to an aircraft. Bones, muscles, and skin were never designed to endure the forces normally associated with supersonic flight. So why didn't his body tear apart? The answer begins with something most people never think about: the air itself. At nearly 39 kilometers above Earth, the atmosphere is dramatically thinner than it is at sea level. In fact, only a tiny fraction of the air remains at that altitude. With fewer air molecules surrounding him, Felix experienced far less aerodynamic pressure than an aircraft flying near the ground at the same speed. That single difference changed everything. The lower air density dramatically reduced the intensity of the shock waves forming around his body. Instead of producing the devastating forces engineers normally expect near Mach 1, the surrounding airflow behaved very differently in the upper atmosphere. The thin air acted almost like a protective buffer. Pressure was distributed more gently around his body instead of concentrating into destructive forces. His specially designed pressure suit also played an essential role. It maintained internal pressure, protected his body from near vacuum conditions, and helped stabilize his posture throughout the descent. But contrary to what many people believe, the suit alone was not the reason he survived. The real hero was physics itself. Gravity accelerated him downward. Thin air reduced aerodynamic stress. Careful engineering controlled his stability. Every factor worked together with extraordinary precision. Eventually, Felix became the first human to break the sound barrier during freefall without the assistance of an aircraft. He reached a maximum speed of more than 1,350 kilometers per hour, faster than the speed of sound at that altitude. What looked impossible to millions of viewers was actually the result of years of engineering, atmospheric science, and an extraordinary understanding of fluid dynamics. Felix Baumgartner didn't survive because he defeated the laws of physics. He survived because he understood them. Sometimes, the greatest discoveries don't come from breaking nature's rules, but from learning how to work with them.